Hello, everyone. Welcome to Rational Science directly from Frankfurt, Germany. Last week, we didn't have a show. We were involved with a little tragedy that happened within our family, and that's that one of my brothers, they amputated his right leg above the knee because of diabetes, and half his body was paralyzed. So, we were with that issue last week. And it's interesting that he's an atheist, and his brother-in-law, he married a Japanese woman, and the entire family on her side, Japanese, pretty much all the boys did judo. They were Buddhists, and they were judo practitioners. Okay, and there was one of them, 17-year-old, and he was quite athletic. And one day he did a somersault in the air, and he fell on his neck. And overnight, in a matter of seconds, he became a quadriplegic. The doctor said he might live maybe 2, 3 years, and he lived to at least the age of 52, I think. He lived like 35 more years. And it turns out my brother had talks with him since he was a Buddhist, when he was completely paralyzed, sitting in a bed for the rest of his life. His parents took care of him. And my brother asked him if he thought that was worth living, that kind of life. And the fellow told him that he had no problem with it because he was being punished in this life, and that in his next life he would come back in better shape, as who knows whatever. And so it gives you a little bit of a lesson that maybe religious people here have an advantage over atheists who don't believe in a second chance, pretty much, right? And so now my brother's in that situation. And the question is whether he would choose to die or to live like that for the rest of his life. And that's a question for you. How would you do it? What would you do in a similar situation? And I'll put the same issue in a different context for you to ponder. Would you like to be the last human on earth? Okay. Here you are all alone, no one to take care of you. Maybe you get sick. The problem with people who are all alone, they have to take care of their own health. And it's easy to talk about health when you're 30 years old, but it's a little different when you're 60, 70, or 80. And so think about that as well. Okay, so let's get on with some of the questions that people ask regarding extinction and that subject. But let me start it with this. Okay, I have a statement that I always put out there. I say, we are the last generations of humans on Earth. A lot of people ask me about that, especially everybody wants to know when. Tell them I'm not an astrologer. Okay, I don't do astrology. Okay, so what is a generation? Well, a generation just means that we don't have a long time to go. We don't have too much time ahead of us. Whatever that means to you, everybody has to use their own criterion, right? Whatever notion you have of time, of how much time it's going to take for the world to collapse, for the global economy to collapse, and subsequently, be followed by the collapse of the food chain. Okay, and so I don't give a date because I consider a generation, again, a very general term. I have to put something in there, and I put the word generation, meaning that we're very close to extinction. That's all that generation means. Okay. And I gave the example the other day, I think it was, of who was it? Of Galileo and Newton. Were they of the same generation? They were both from the 17th century, but Galileo died the year that Newton was born. Should we consider them of the same generation now that we look back at that piece of history, or should we consider other people of being of the same generation as Galileo and Newton? So, again, what is a generation? Well, it's a very vague term, and it's deliberately vague in my theory because I don't give a date for extinction. Okay, let's move on to the questions now. Yeah, here we have a fellow says, do you accept that catastrophic events might have been the trigger for mass extinctions? For example, the asteroid impact before the end of the dinosaurs, for example, right? Setting off a food collapse that was latent or in the making, because there seems to be a lot of evidence for such catastrophic events. And I wonder how this fits in with your proposed mechanism. Well, no, I'm saying that catastrophes have absolutely nothing. None of them have anything to do with any of the mass extinctions of the past. Mother Nature does not work through catastrophes, especially, coming out of the sky, came out of the sky. Asteroids, comets, supernovas, all those things from the skies, okay? None of those ever happened. Volcanoes, in the case of Permian, one of the most popular ones is the volcano theory, that there were some volcanoes or maybe even some underwater eruptions. Okay? And so I'm saying none of those had anything at all to do with extinction. Catastrophes don't have anything to do with extinction. And the main argument I've got against that is that you cannot, with a catastrophic accident, explain selectivity. You cannot explain how Mother Nature got rid of some animals, plants and animals, and left other plants and animals alive. And when you look at the history, just by sheer coincidence, it's the old plants and animals that vanished in a mass extinction and the new ones that continued. And that happened in every extinction. You can't produce that kind of selectivity, chronological selectivity, with any kind of catastrophic accident. So you cannot explain selectivity with catastrophes, period. So they have absolutely nothing to do with mass extinctions. What you got to explain really is how a food chain disappears and another one remains, because that's exactly what happened. And of course, if one food chain disappears, well, you have to believe that what happened was that the primary production is what disappeared essentially. Not that it disappeared completely, but the islands shrank, other plants took over, and the animals that were tied to those shrinking islands, those were the ones that disappeared. That's essentially the theory, okay? And so, no, in fact, here I have a chart, a little graph there. It's known as the Cretaceous Terrestrial Revolution, which I have shown in the past. And it's when the flowering plants took over the land, which are the red graph there. And you can see that the angiosperms muscled all the other types of plants aside in the last half of the Cretaceous. Okay? And when you look at that, you say, okay, I see what happened. If the dinosaurs were tied to the cycads and to the conifers in general, well, you can see how those suffered greatly at the hands of the angiosperms. Okay, so it's the gymnosperms that disappeared essentially, and today we have relatively few gymnosperms on the planet. And all mammals, they don't eat gymnosperms, they eat angiosperms. Okay, and so it is a food chain phenomenon. That's what I'm saying that mass extinctions are. Okay, so again, that's my take on that. My 5 cents worth. That's my theory. Another issue a person raises, he says, birth rate is low due to empowering women, not urbanization. Well, I think he's still stuck in the Stone Age. He doesn't want women equality. He thinks that's bad. And yeah, all I can say is every age had a different type of family. Okay, we had patriarchy, we had matriarchy, we had before that, right? We had nuclear family, and today we have more or less the bachelor. That's where we're headed. You know, there will be no marriages in the future. It'll be casual sex, maybe here and there, and hopefully nothing, no productivity. Why? Because we moved to the cities. We have high density, and again, it's what I showed with a couple of those videos last time, where you see the fruits, or it could be a vegetable as well, and the bacteria just first multiply, and then as they multiply and you have more bacteria, well, then the whole thing shrinks and eventually collapses to zero. And unless those bacteria can move on to some other mountain of food or whatever, well, they die as well. That's the end of them. So that's essentially explains what is known as density-dependent birth rates. Okay? The more the bacteria, or any animal for that matter, I mean, the bacteria are kind of in between, but if you take any animal and you have lots of them, the more you have of them in a given size pen or whatever, eventually, at some point, the curve will turn around and they'll start having fewer children, fewer offspring. Okay? And that's known as density-dependent birth rates. Humans have been shown to experience density-dependent birth rates as well. That means that when you get into a city, you're going to find fewer and fewer children. And if you want to see children, you got to go more out into the country. It's that transition that's created the low birth rates. Okay, another question, another issue. Paul says, as a Marxist, you will never understand money, and therefore your theory of money and food will always fail. Ask yourself, Marxist, why do people produce? That is the question you do not understand. Oh, I see, okay. It is called self-interest, okay. Why do you produce these videos? For the money you get, which helps you to satisfy your self-interest. Well, first of all, there seems to be a contradiction there, because you're saying, I cannot understand money or why people do things, and then you say you're doing this because, so it looks like I do understand maybe, right? Right, okay. But no, there's a different argument. No, I don't do these videos for money. Absolutely not. I don't make any money out of this. I have some Patreon supporters, and I do thank them. But that's just to keep the channel alive. I can't live off of that for sure. I'd starve to death, okay, before the extinction. No, I do this because I absolutely love physics, and I do a lot of research on these subjects, also extinction, by the way. And so I do this just for the fun of it. I have no reason to do this other than that. It's a subject I enjoy and I'm very passionate about. And so that's it. That's the end of it. So, this notion that people do everything for money, no, there are other reasons. And I had another question along the same lines. And the fellow says the following. Let's see if I can get this up here. Oh my God, went on the other side. Give me a second here. He says, money is what motivates industrial espionage. I used to be a spy, so that's what he's referring to. Regardless of whatever pitiful secondary justifications you come up with while you're in the dark. Okay? Wrong again, just like the other fellow. They're both quite wrong. Especially when you're a Marxist. I used to be a Marxist, in other words, in the sense that I believed that that communism was going to take over the world, and I did support that during many years of my life, at least 20 plus years. And I didn't do it for money. Absolutely not. It had nothing to do with money. I never got a penny for that, for that kind of spying. In other words, in my case, I approached the Cubans, and the reason they were willing to work with me is, first, I told them that who I was, and what I was doing, and what I could do for them, and then that I was doing it for free. Why? Because I was a Marxist. And so once that was cleared up and they could verify that through the fact that I had requested a visa, a permanent resident visa to go to Cuba when I was young. And so they saw that. They saw that I was in the Communist Party of Argentina. And so they decided that they were going to work with me. And throughout that time, I never made a penny. It was never done for money at all. In fact, it turns out that when I turned myself over to the CIA and the FBI one day, Mr. King, Jim King, who was handling my case, he was the case agent from Austin, Texas. And we were discussing one day at my table in my dining room, and I don't know how the conversation came out, and I told him at one point, I said, I didn't do this for money. And he looked at me straight in my eyes and he said, yeah, we know. And it's like he couldn't believe that someone would do it for anything other than money. And what you have to understand is people do things for ideology. And so this notion that you have that everyone does it is a prostitute, maybe like you, who only does things for money. I mean, I don't know how far you're willing to go. What are you willing to do? Maybe have some safe sex, maybe, with someone for money. People do things for things other than money, and they will not do certain things even for money. So to say that everything is done for money is just insane. And I'm sure that you don't believe it yourself, okay? So no, I never did anything for money as far as, the spying business. The other issue you should be aware of, when I was in prison, I got 11 people out of prison, which owe me their lives. Okay, I guess they connected me back. Jailhouse lawyers who charge to help inmates, their fellow inmates, and they charge quite a bit. They charge like $2,000 to handle their cases and do their motions in court. I did it for over 100 cases while I was in prison. I did that almost on a daily basis. I dedicated some time to do motions for inmates, and I never charged them a single penny, not one penny. I did it because I wanted to screw the system. I wanted to get back at the system, partly and because some of these guys had, I think they had a valid case. And again, I was able to get 11 people out that never had any idea that they would ever be out of prison. And I got them out as a jailhouse lawyer. And I got them out for free. They felt so compelled to pay me back for what I had done for them that they would give me whatever they could, maybe stamps or envelopes or whatever that, I could use. Sometimes they would bring coffee or stuff like that, but I never charged them a penny. So people don't do things only for money, and certainly not me. I don't do things for money. Rarely do I do something for money. I did my regular work at AMD for money, but not spying. Okay, let me move on to another question here. Fellow says, humans were surviving long before we invented money. Yeah, we were surviving on something called food. Otherwise, we wouldn't be surviving, okay? And no, we didn't trade food, so we didn't use it as money when we lived off of food exclusively, like, when we were hunters. And yeah, so we were surviving, but we were surviving not because of money, we were surviving because of food. And today the problem is that food is produced only because of money. And so I don't know if you can tie two and two together there, but it turns out that if there is no money, there is no food. Okay, and another fellow asked along the same lines, a question along that same line, or makes a comment. He says, removing all money won't remove all food. Okay, however, it likely will reduce food supply considerably. I'm sure there will be a lot of pockets of survival. And again, this is where we have a big problem. People don't believe that if money disappears, you cannot rationalize this, that if money disappears, food disappears. No one will produce or distribute food. Whatever food you have, you keep to yourself. Whatever food the farmer is planting, he will keep to himself, and he better be able to defend it, which he won't be able to, because he's going to have acres of land. He's got to have acres to feed himself and his family, if he's got a family, right? And he's not going to be able to patrol his whole garden from city folks, which will just run over his land. and just take away his corn, his lettuce, whatever he's got there, his cows, he's not going to be able to protect his holdings all by himself. And he can have a group of people, it still won't help because he's going to be fighting thousands of people, a lot of them armed. Others will just come and steal whatever he's got. There's no way he can control the land. So there won't be any food after the global economy collapses. And we have no money on the planet. No one does trade anymore. And it's incredible. People have trouble understanding that. And here I'm not yet at the point where you say, well, how does money disappear? Right now, that's an irrelevant question. I'm saying if God comes in with his magic wand, makes all money disappear just by magic. Nobody believes in money. No one trusts in God anymore, you know. In God we don't trust. At that point, we stop producing food, and whatever food there's on the planet, that's it. And, you know, whether hidden or out in the open, and then whoever has it, that guy lives a little more than the other guy probably, and then they have to defend that food. But no one will be producing food because you won't have time to wait for the harvest, first. And second, you know, while you're planting, someone comes over and says, okay, thanks for the job. Here, why don't you take off now and I'll collect the harvest. You know, defense will be the problem. You know, you won't have 911, you won't have the courts, you won't have the police, you won't have the military. Everything breaks down when there is no money. Money is what holds it together today. Okay, so no rich person will be able to compel a poor person to do anything because what is he going to bribe him with? Money? Okay, so money is the key issue. When money disappears, that's it for all of us. Okay, and so here's another issue question. Fella says everything would have to be extinct for your theory to work, and everything does not go extinct in past die-off events. Well, everything did not go extinct because everything does not need to go extinct. So I don't know where he got that. In fact, when one food chain disappeared, the other one continued rolling. Why? Because the food chain that disappeared had nothing to do with a food chain that kept going. That's what it's all about. I mean, let's just make an assumption here. Let's assume that when mammals, essentially that's going to be the sixth mass extinction, what it's going to be about, mammals disappearing. When mammals disappear, and let's assume the insects take over the land, okay, just an assumption here. Okay, so the insects take over the land. Are we going to kill all the insects? No, we're probably not going to be able to wipe them out. We're going to be eating mammals, you know, cows, pigs, maybe we eat chickens and some other animal that we have out there, and that's it. We wipe them all out. They're out of the, they go into extinction. We might even kill all the lions. We'll kill all the elephants. Anything that walks, we'll kill, and then we'll kill each other, and we're out of the picture. You know, the insects can take over the land. You know, they start radiating. You know, and those insects that can adjust to weeds, because the foods that we grow today, the plants that we grow today, primarily the grasses, they're going to disappear with us. That's why we died, because there were no more grasses, or very few of them. And what continues are maybe the weeds or some other plant that goes out there, maybe some carnivorous plant or whatever. And whatever little insect that maybe feeds on that, those will radiate. They will occupy their niches and eventually maybe grow to bigger sizes like in the Carboniferous. You had dragonflies, which had meter-long wings, and they're little airplanes. Okay, so we don't know what's coming next, but assuming it's the insects, for sure we're not going to wipe out all the insects. Okay, no one's going to take the trouble to hunt for insects out there. Okay, and so one food chain disappears, another one stays. So everything does not disappear with a mass extinction. So I don't know where this guy got the idea that everything has to disappear if food disappears. No, what's food for us disappears, but what's food for something else that we don't eat or have anything to do with, those are untouched. You know, nothing will happen to them. Okay, another issue, another question. Fellow says, fell on the other side. So touchy. Okay, here it is. Fellow says also, food will never end. Raw meat from almost all animals can keep mankind going forever. So the guy really believes that mammals, that is primarily what we eat in terms of meat. We obviously we eat chickens and fish and so on, but in general, he's saying all the animals will stay there and we'll have meat forever. My God, and they really believe this. They really think that this is the case. And no, one issue is that we grow a lot of these, or raise these animals. Why do we raise them? Well, because we eat them, we kill them and eat them. Some people think that's immoral to not even hunt them, that just to grow them in a pen and just kill them at our leisure. But yeah, all that's done for money. Butchering is done for money. That's the bottom line. And so, money's gone. There's no reason for this person to have cattle or pigs or chickens or even fish. So no, when money disappears, there's no reason to raise these animals for the market. And if the guy grows them for himself, he better watch out that he doesn't get visits from thousands of people from the city. Okay, that's the issue there. Okay, and all I can say is what I always try to say. Very few people address this. Some do. Okay. And that's this one, that you got to do Extinction 101 before you do 102. Everybody's an expert on how humans won't die. No one's an expert on how animals in the past did die. Okay? So please address Extinction 101, which is the issue really here, mass extinction, and don't go so quickly to human extinction. Figure out if you can tell me what caused the extinction of animals in the past. And hopefully you will not use any of those catastrophes, supernovas and asteroids and comets and all that kind of stuff. Okay, so let's get to the issue today. The issue today is holy geometry. Some call it sacred geometry. Sacred? What is sacred about geometry? I mean, are we supposed to pray here? What is this sacred geometry? And so, yeah, they have these notions, and I think it comes from people who are deeply religious. They're mystics, way deep inside them, and they want to think of themselves as scientists, as mathematicians, as geometers, whatever. And they come across as, no, I'm a scientist. And what they are is simply deeply religious people. Okay. Well, let me start with where essentially I ended up the other day with just showing what's the problem with geometry. So we have a, oh, sorry, got the wrong one here. Give me a second here. Got the one from the questions at the end of the show. Okay, let me get to the conclusions here. Okay, and so those were conclusions about geometry, essentially. And essentially, mathematical figures are not figures. Okay, that's the arguments I made for the last month or so. Math physics only has itineraries. That's what I showed there. In fact, here's a couple. I'll put it side by side so you see what I'm talking about for those who missed the shows. Okay. Point is not a point, a line is not a line. A point is a location, and a line is a bunch of locations, meaning an itinerary. Okay, so we're not talking about geometric figure. So we need to know what a figure is before we do all this. And in geometry today, we have no figures because they're all done with motion, okay, and time. And so a line, circle, etc., a bunch of locations, that's all they are. All math solids are hollow. Okay, not one of them is a solid. The tesseract, which I had here as well, let me show you that. Give me a second here. Tesseract there, you can see, is not four-dimensional. What you see there in front of you is a three-dimensional cube on a two-dimensional platform, you can say. And then the one on the one that they define and describe, you can see it's supposedly some 8 cubes that come out of nowhere, magic wand. And so it's nonsense, okay, because That's not a figure. It's some kind of movie of something, of a cube turning into 8 cubes. That's what that is. No, the tesseract is, if it's a figure, it should be standing still, it should not be moving, and it should look something like the one where it says what they illustrate, that blue double cube or nested cubes that you see there. And that is a three-dimensional, again, two nested cubes onto a 2D platform. That's all that is, objectively. Okay? You don't have to read more into what you see in front of you. Okay, hypersphere, not equal to four-dimensional either. As you can see there, it's just a balloon that it's growing. That's all it is. Time is supposedly the fourth dimension that is invoked to make that image there. Torus, a bunch of locations. Okay, that's all it is. Itineraries, and when rotating square, cube, tesseract, or any of those, mathematicians are spinning motion itself, time itself. Okay. Okay, so that's where I started, but again, we have to go back to find out what is a figure. And the answer there is that we have to define what an object is. We have to do that for the purposes of physics, and we do that here. And we need to know what an object is for the purposes of physics. We have to find a criterion. That's the issue, or criteria if it's more than one. And the main two that everybody uses are see and touch. Everybody thinks that an object is that which you can see and touch. They also say that an object that exists is that which you can see and touch. Okay, and so the word object and the word exist are synonyms when they use it like that. And we're saying that no, you can't use see or touch because not all objects can be seen, not all objects can be touched. Whereas all objects have shape. It's the universal property. All objects have shape. Okay, and none of those other ones qualify. You know, it's not an object is not that which has mass or volume or that moves or that what it's made out of. It's not the subject of a sentence. It's not a noun. It's not that which has color or, you know, whatever. Anyway, you want to put that. It's not an object it's not that which exists. Okay, and some people also say that concepts exist, like love exists. You know, no, not in physics. In physics, only objects can be said to exist, and it's not that which is 3D. Okay, because there are 2D objects. 2D objects have shape, and they're not 3D. Okay, so there's all those are rejected. The only one that we can use in physics is shape. That's the criterion. No, we don't have to define shape because we're only comparing it against the other criteria. Okay, that's why we don't have to define shape in physics. We don't continue defining forever just to please the devil's advocate. All we do is we say, look, we got to choose a criterion. Which one are you going to choose? And when we have to choose a shape, it's the only one that's applicable. All the others fail. You can't use them to define the word object. That's the one we're concerned about, not the word shape. We're concerned about what is an object. Okay? You don't know what shape is? Go to kindergarten, show them a cube, show them a ball of the same volume, same mass, same everything, and ask the kids, what is the difference between these two? And they'll say, it's the shape. They'll teach you what shape is. Okay? So if you don't know what shape is, go to a kindergarten and they'll teach you. Okay? Okay, you must have missed the class. Okay, a person asks then, he says, well, does the Mandelbrot set have a shape? And okay, if you look it up, you'll find an image that looks like the one you see there. And I look at that and say, well, yeah, that has shape. We're done. So if that's what they call a Mandelbrot, and we'll stop there. We won't put anything before or after that. We'll call that a Mandelbrot. We can call it X as well. We say, yeah, X does have shape. Straightforward, we're done. Okay? What's the problem? Well, the problem with Mandelbrot is more or less like the problem with the word shadow. You have to find out what the word shadow means, and you got to find out what a Mandelbrot set is or means or stands for. What is this? It turns out that you got to use that equation to calculate points, where to put the points on that image. Okay, that's what that equation is all about. And some say that it's just as famous, or not quite, but at least it's just as important or whatever as E equals MC squared. Also which was attributed to Einstein, which I think it should not have been because that equation existed before Einstein. But, this Mandelbrot's got that equation. That's how they calculate each point. Then they take that point and they calculate it again. They just do this iteration, okay, forever. And so the Mandelbrot set is something in motion. So if that's what Mandelbrot set, or just Mandelbrot, if you just want to call it Mandelbrot, means or stands for, that's not a geometric figure. What I have in front of us is a figure. It has shape, and I don't have to do anything with it. I don't have to look deeper into it and find out if it's got little points in between 2 points. We don't care about any of that. We say, does that have shape? Yeah, it's got shape. It's contoured all around. It's got shape. We're done. So what's in front of us, does have shape and is an object, a figure. All these are synonyms. Okay, a thing. Okay. Now, what do they say? What is Mandelbrot according to these people? Well, they say something else. This is what they put it in motion, and here you can see a little image of this. Okay, and you can see how this thing is growing. Okay, and what you got to do is zoom in, zoom in, zoom in, zoom in all the way. Okay, and all you do is all day long is just zoom in on this, and you can see these patterns in there. Okay, and so the question is that a geometric figure, what you're staring at? And the answer is no, because it doesn't stop moving. Okay, so here you see it. You see how it's just zooming in all the way forever. That's essentially what they're saying here. That's what a Mandelbrot set is. And no, that is the one on the right is not a geometric figure. First of all, because it doesn't stand still. Okay, it's got time involved, it's got motion involved, and an object is not that which moves. It's not that which has time. An object is what you see on the left, that which has shape. Okay, the one on the right, we don't know if it has shape because it keeps moving. We don't know what we're staring at. It's got to be standing still in order for us to determine whether it is a geometric figure. Okay. And then let me show you this. Here it is. There's this description for these kinds of patterns that you see on the right. That says, by the end, the magnification of the original image is 3e to the 2,159 power, right? And yes, that is a 3 with 2,159 zeros after it. To zoom into an image smoothly, you must magnify it exponentially. In this case, the magnification doubles every 1.5 seconds. The human mind has great difficulty comprehending exponentials. For comparison, the width of the observable universe is about 9e26 meters. Okay, so what these people are saying, that you got to zoom in, and that's how you create any of these images. And there's several of these. That's the Mandelbrot. That's probably the most famous one. But here you have some other sacred geometries. I call them holy geometries. Okay. People make these videos. You can look them up. Those are the titles of the videos. Those are the images, the icons they put out there. And you can see they have all these fancy pictures there that a lot of people like to look at. They're like kind of hypnotized by them. They love to look at this stuff, and just zooming in into their eyes, and I guess with a little music in the background, they fall asleep and they say, "Oh, that was so nice." And some of these have thousands, hundreds of thousands, and millions of viewers, and not only viewers, I mean followers. You say, well, what do these people have in their minds? Is this just to relax and look at these? You can call it art. Is that what it's all about? I mean, what does this have to do with geometry? What does it have to do with physics or science? Is this how it's put forward? Or is it just put out there as art? Is that what all this sacred geometry, this holy geometry is about? Okay. And so, a lot of these people, they just would like to watch this stuff. And so I call them, I say these people are religious folks. They just look at these patterns, they're hypnotized by them. And this is what they like to see. They like to see all these patterns. And that's fine. I mean, if you like art, that's great. I have no problem with that. But to call it geometry and to say that this has something to do with geometry, with figures, or that this has something to do with science, or with physics, absolutely not. This has absolutely nothing to do with physics. You want art, fine, but why bring it into physics? Why bring it to sneak it in through geometry and say, well, this is geometry. We calculate all this with, or we design these patterns with mathematical equations, and then we put it in motion. We have all this stuff zooming in front of our eyes. Yeah, if you want to hypnotize someone, I guess that works, right? Is that what science is about? Again, science is about explaining, and this certainly doesn't explain anything. Okay, and this is what some of these geometric figures look like, and they're like the Mandelbrot set that you saw a minute ago, okay? And you can see these are different ones that I've just made a collage of, and you can see how they're just zooming in on all these patterns. So what is this? This is art? Great. He who likes to watch this stuff, fine, you can do this all day as far as I'm concerned, but this has nothing to do with physics. Okay? And so, yeah, I think these people, when they bring it into geometry and they call it geometry, they're kind of trying to sneak it into physics, like saying, oh, I'm a scientist. No, I agree that you're an artist. That I can agree with. I cannot agree that you're doing science by showing me this zoom into this so-called sacred geometry simply because you have an equation that plots the points that make these patterns. And all these Mandelbrot sets and all these images are really what they're doing is they're saying let's take the microscope and zoom in ever higher. And so you go from, I don't know, 1000x microscope to a SEM, to maybe atomic force microscope. And you can zoom. Maybe tomorrow we'll invent something more powerful, or maybe some kind of telescope that looks in there. And so all you keep doing is just looking at the fjords, so to speak, and making the fjords more visible, and then you're measuring each little nook and cranny in those fjords. That's what it's all about. And so what does this have to do with science, with physics, or geometry? Assuming you want to introduce geometry as part of physics. Again, the part of geometry that belongs to physics is the figure, not the equation, not the relation. What belongs to physics is the figure. The rest belongs to math. And there is no such thing as mathematical physics. Math is math, physics is physics. You want to do math, you want to calculate these things and get entertained by the art. Well, that's one thing. Don't say that you're doing physics or that you're a scientist. Scientist is a guy who explains something. That's why we have to distinguish an explainer from a describer. The guy who goes to the art gallery, he's describing. He's not explaining anything. He's just looking at a picture and saying, oh, it's got the blue here and the red there and this line here and the other one is straight and the other one is crooked. That's the description. Art is worthless as far as explanation is concerned. Okay. So here we have another type of these sacred geometries. It's known as the Koch curve, or the Koch, Koch snowflake. Okay, and here's more or less the description of this, and essentially how you build this thing. Okay, it says you start with an equilateral triangle, and on each side you take a piece that you substitute two pieces that are now longer than the original piece. And for those two pieces, you substitute two pieces that are each longer than the original piece. You do this over and over again. You get the same shape, but now each line has that little triangular bump on it. You break it again and again and again. Each time you break it, the line gets longer. Every iteration, every cycle, you are adding on another little triangle. Imagine iterating that process of adding little bits infinitely, many times. What you end up with is something that's infinitely long. Okay, and notice they use this word infinite. And it says the Koch curve was a paradox. To the eye, the curve appears to be finite, but mathematically, it is infinite. which means that it cannot be measured. Okay? And here you see, again, a dynamic version of the Koch curve, or snowflakes. Let me see if I can get this thing up here. Here it is. Okay, you can see what it looks like. Okay, they like to watch these things. They like to hypnotize themselves with it. So what's the problem I have with some of these things? Let me get myself in here. The problem I have is this notion of infinity. There's nothing infinite about what you saw there. First of all, the word infinite is an adjective. And what these people are trying to say is that they're saying incessantly. That's what they're using. That's the notion they're using, but they're using the word infinite in lieu of the word incessant, or incessantly, the adverb incessantly. And what they're saying is, if you do this incessantly, if you do this over and over again, if you do it incessantly, perpetually, forever, okay, then you're going to get those patterns, and you're going to be, again, looking at the nooks and crannies of the fjord that you're zeroing in or zooming in on. Okay, and you can do this over and over and see more fjords, more little nooks and crannies, and you say, well, you can't measure that. Why? Because it all depends on your measuring stick, how big or how small you make it. Okay, and the more you see, the smaller you make your stick, and within that, you expand that 1 billion times, and now you got to get another stick to measure the nooks and crannies there, and so on down the line. And so they call it infinitely. Well, the image is not infinite. All objects, all figures are finite. But what these people are saying is that the itineraries are infinite, okay, using that word, meaning that you can walk incessantly around this perimeter, because there are more points in between any 2 points. That's essentially what they're saying with all this. So you can find more points between any 2 points that make up the perimeter, which make up really the itinerary around the perimeter of the image in question. And so they say, well, from a mathematical point of view, if you keep putting numbers in there and calculating, well, you can go on forever. It's incessant. Okay, you can continue putting points or numbers as much as you want. That's got nothing to do with the word infinite, which is an adjective that is used to qualify objects, and there is no object which is infinite. Okay, all objects are finite. So the word infinite, for the purposes of physics, is an oxymoron. You can only use it with objects. You cannot talk about infinite love, not in science. Okay, you can talk about an infinite table, but there is no such monster as an infinite table, because all tables are finite. So an infinite object is an oxymoron, because what you're saying is an infinite finite, essentially. Okay, that's what it comes down to. So infinite is a word outlawed in science. Okay, you can use the word incessant if you're going to be doing math or talking about itineraries or about incessant motion, perpetual motion, or whatever. You can talk about it moving incessantly. That's one issue. You can't use the word infinite in that context. The only way you can use the word infinite with objects, and there is no such thing as an infinite object. That's the bottom line. Okay, let's see if we can get to the questions today, some of the questions people asked. And again, here's this fellow. He says, I asked 3 questions. This was during my, the monthly recap with Hans, my son, last time. And he says, I asked 3 questions twice and they were skipped over. Oh, I'm so sorry. Excuse us. Okay. How do ropes make the Poisson spot in Fresnel diffraction? How do ropes make phyllotaxis? How do ropes make the toroidal pattern and block wall in magnetism? I want to add another question. How do ropes make the frequencies of different color light? Okay, let's see how we answer this. Okay, we have a couple answers here for this gentleman. And here's the first one. Okay, and it goes like this. Because, we might also look at other participants, okay, questions and comments that they make. And no one has a monopoly over the airspace here, okay? So we can't just look at one guy and say, oh, we're just going to answer all your questions alone. Then the questions this fellow is asking, are a little interest in physics and highly specialized. A lot of the visitors aren't interested in these subjects at all. Okay, so it's not like we're going to drop other subjects which are more popular or more down to earth and just answer these highly specialized questions on the run. Okay. And most visitors are not even aware or care to be aware of what those far-fetched mathematical issues are, because all these are essentially mathematical questions. Okay, that's what this fellow wants to know. He doesn't want to know a mechanism because he's not interested in mechanisms, and I'll go over that in a second. He's just interested in getting a mathematical type of answer for these things. Then the issues have no current rational explanation for this individual's religion of mathematics. Okay. How does he explain any of these phenomena? Does he have an explanation for this? I mean, if he wants an explanation, does he have one to begin with? I mean, is he challenging whether we have an explanation and like saying he does and he's saying we don't? Okay, so let's go through each one of these. Okay, here's the Poisson. Okay. And this is the answer here. What is a Poisson spot? Okay, a bright point. This is from I think Wikipedia. Bright point that appears at the center of a circular object's shadow due to what? Fresnel diffraction. Okay, so it's just a diffraction, a specialized type of diffraction, and we've explained diffraction in the past. Okay, and the way you find it today, and there you see it. This spot played an important role in what? In the discovery of the wave nature of light, and is a common way to demonstrate that light behaves as a wave. And the question here is, there is no physical object called a wave. Wave is a verb. It's not a noun for the purposes of physics. You can't say that light is a wave, that it waves, that there's a wavy motion, that it behaves as a wave. Yeah, you can say that. You cannot say that light is a wave, and until we know what light is, we cannot explain anything about light, especially diffraction. You cannot say, well, light moved as a wave, whatever light is, but it moved as a wave, and that's how we do diffraction. Interference fringes and so on, interference patterns. That's not an explanation. You need to know. You need to be able to propose what physical entity mediates light. Okay, that's the first step. You don't have an object that can do light. You don't have a theory. You don't even have a theory. Now you can say particles, assuming they're real particles like corpuscles, classical corpuscles, then yes, you can try to explain it with corpuscles. But you cannot say wave because there's no such thing as wave, and you cannot say that your corpuscles are really quantum particles, which are not particles at all, which are just equations and wave functions. That's nonsense. Those are not physical objects, and quantum mechanics does not have a physical object at all. So there is no theory of quantum mechanics. All there is a description. That's all it is, and descriptions are not science. Science is explanations. Okay? And so there is no such thing as a wave. So the onus shifts to this individual to explain the Poisson spot in rational terms. Okay, in other words, without reification, without concretization, turning a concept into an object. Okay, so you can't use the word wave. Please explain what physical object created the Poisson spot. That's the question. And if you can't answer that question, well, you don't have a theory. We do have a theory, and we have explained diffraction in the past, many times, in fact. And no problem, because we do have a physical object. It's called a rope. And rope, two-strand rope, yeah, you can explain interference, one rope with another rope, which is what the Poisson spot is. It's a diffraction pattern, and diffraction is done with physical objects. Okay, light is a physical object. And that's where the problem is. People say, well, what do you mean a physical object? I can't see it, I can't touch it. Yeah, because an object is not that which you can see or touch. That's the wrong definition. And the correct definition, or the scientific definition, is that which has shape. A rope meets that condition. Okay, phyllotaxis. Let's see what that is. Okay, and here we look it up also at the Wikipedia. And this is what you find. You find phyllotaxis is the arrangement of leaves on a plant stem. Okay, especially if they're curled around, that's what these people usually talk about. You know, phyllotaxic spirals, okay, form a distinctive class of patterns in nature. And let's find out how they're formed. That's what comes next. The pattern of leaves on a plant is ultimately controlled by the local depletion of the plant hormone, auxin, in certain areas of the meristem. And it goes out there and then it explains how these phyllotaxis patterns are formed. And, you know, I don't see where we have to explain anything with the rope here. Okay, all that these people are saying is that there's a hormone that is causing this, that causes the plants to curve, okay, and to twirl around and to spiral. But we go the extra mile and we do have the following, okay. We do have, if you go to the book, Why God Doesn't Exist, my book, you'll see something that looks like this. And that's collagen, and also in the case in the one on the upper right, you'll see the water molecule, essentially how water is connected. In other words, how oxygen is connected to hydrogen in water. And what you see is the hydrogen bond, and hopefully that bond is a physical entity, and we're saying it's the rope. Okay. And then you have the covalent bonds, and those are where you have merged shells, electron shells that encapsulate the nucleus of the atom. And at the bottom you see collagen, which is again a stringy type thing. Okay, and the question is, how are all those atoms connected if they form collagen? If all these atoms are just loose, you know, then you wouldn't have a molecule called collagen. The reason we have this stringy molecule is because they're all connected. And so, yeah, we do have an explanation for that, and the explanation does come from the fact that all atoms in the universe are interconnected physically. Then you can explain, you know, how these molecules form. But to say that that molecule over there, or that atom like hydrogen in the case of water, is connected to oxygen over here, from far away, from a distance, well, what is connecting them? Why doesn't the hydrogen fly away? Why doesn't the oxygen fly away? And so hopefully there's a physical interconnection between those two atoms. You know, so if you have two H and one O, well, you have the water molecule. Why doesn't the H fly away? Why doesn't the oxygen fly away? Aren't those gases? You know, usually in gaseous state, if you have O2 or an H2, don't they fly away? So that's the issue. The issue is, how do you form a molecule if you're not going to put some interconnection between the atoms? Okay, and that's essentially what we explain with the rope model. Okay, and regarding frequency that he asked, how do you do frequency with a rope? Again, we've explained this in the past, and here it is. Let me make this a little bigger. And it's, we do it with a prism here. It's very easily explained with that. You know, in the case of quantum mechanics, it has no explanation, because you have either waves or you have particles, which are the two on the top. And in the case of waves, wave is not a physical object, so you haven't explained how light has frequency and wavelength, you know, because you don't know what the physical object is. There is no physical object called wave, and you have to identify that physical object before you can talk about waves. What is waving? That's the question everybody has asked for now, what, hundreds of years? And in the case of particles, well, if they're particles, well, yeah, corpuscles, you know, classical corpuscles, fine, you can try to address that. But see, in quantum, they don't have corpuscles. So what you're seeing there is the classical model. Assuming that we're talking about real corpuscles, little balls, well, there's too many questions to explain. You cannot explain wavelength if you don't have waves. And in the case of particles, you would have to move them up and down, because the transverse motion or wavy motion of the waves, that's what's called the transverse wave, you cannot reproduce it with those particles. Why would the particle go up? Why would the particle go down? What physical object is pushing the particles up and down to create this up and down wavy motion, for example, the electric field or for the magnetic field. You cannot explain it with particles because you cannot explain the motion of each individual particle moving up or down. So none of the two above, quantum mechanics can explain, or classical mechanics for that matter, can explain the frequency. Okay? Because you don't have an object in the case of the waves. You don't have an object in the case of the quantum particles, and in the case of classical particles, you cannot explain the up and down wavy motion of light, which is already like ground in stone. We know that's the case. Okay, and the rope is very easy. The rope is already, here you see my famous rope. Okay, it's already structurally wavy, and all you need to do is torque it, and you have a three-dimensional wave. What is waving? A physical object called a rope. Okay, so that's the difference. And then, so when you can see coming out of the prism there, you'll see different colors. Each one has a different frequency, meaning each one has a different wavelength, meaning link length. The link of each rope, of the links for a given rope are different in length than the ones for red, for blue, for the different colors. So yeah, we have no problem with a rope. Here, assuming we'll tighten this up, we'll call this the high frequency. Okay, high frequency. What is it? Many torques of the rope, electromagnetic rope, and so we'll call that one blue. You want red, which is a lower frequency. Well, you untorque it, and now you have red. Okay, because they have longer wavelength, longer link lengths. We call them. We're done. We have a physical object, and now we find why we have frequency. Frequency is simply the link of a rope. Okay, the length of a link of a rope. Very straightforward. We have the object and we have its behavior. Okay, the ones above don't have, either have one or the other or none. Okay. Okay. Next issue. Fellow asks. I think it's the same fellow. He says, an itinerary is having a plan for having a seminar or a vacation plan. What you intend to do today has nothing to do with geometry. The fact that I'm saying that itineraries are what make up each one of these geometric so-called figures. And again, he's just making a statement, emotional statement, but he's not answering the question. The question is that all the descriptions, all the definitions of geometry are itineraries. I didn't invent that. That's what geometry is. That's how all these so-called geometric figures, right? That's how they're defined. That's how they're described. They're defined through a construction. They construct these figures. They don't point to them. They say, let me show you how I build a circle. They don't point to a circle. And they're still building their circle because the way they build it, they say between any two locations, you have another locations. And they call them points, okay? And even if they use the word point, between any 2 points, you have another point. And all you do is make it smaller and fit one in there. And so the circle is still under construction. Since the days of Euclid, they have never finished building their circle. We're still waiting for them to finish their famous circle so we can point to it. Yeah, right now they're still building, they're still putting points between every 2 points. Then the fellow says the primary part of description of an object is that it is three-dimensional. The simplicity in it is we can see or touch 3D. And so here's the question here. Here we have see or touch, he says. So let's find out if that's true. Here we have what I showed last time, which he doesn't want to answer. And here we have the Klingon. He's 1 gazillion light years away on the other side of the universe, okay? And he's got a table there, okay? And he sits on the table or eats on the table or crashes it or practices karate with his table, whatever. Is his table a physical object? Is his physical table, which is a physical object, does it exist? And again, you can't see or touch his table. And so the question is that a table to you? Or is it an object to you? And so the question is, if it's not according to your definition, then you cannot use the definition of see and touch or 3D. That is also a 3D table. So you can't use 3D. You cannot use, see or touch. But does the table have shape independent of whether you see or touch it? And the answer is yes. His table has shape. And so we have a definition, and that can be used universally. It can be used consistently, and that is that an object is that which has shape. An object is not that which you can see or touch, or which is 3D. There are 2D objects. They have shape. You cannot see or touch them, depending on what object it is, But there are 2D objects that you cannot touch for sure. If you're blind, you can't see it, and so does that mean it's not an object? It does have shape. So it qualifies as an object for the purposes of physics. And physics only deals with objects that are 3D first. It doesn't have any use for 2D objects. And more than that, it uses 3D objects that exist, that have location. It does not deal with objects that do not have location. Okay. Here's another comment. I think just a summary for this fellow, because it turns out that he doesn't answer a lot of the questions. One puts questions out there and he just avoids them, runs away, and just keeps asking the same questions over and over, or just stating whatever he learned in high school by rote. He's just repeating it, regurgitating. He says, for example, this is what I'm saying against him. He said, saying, we showed that all definitions of the basic geometric figures are itineraries, a series of locations. I showed that. It's in the definitions, it's in the descriptions. I didn't invent all that. That comes out of geometry. Geometry defines a circle as an orbit of a location. The location is orbiting. And that's an itinerary. That's what a circle, that's how it's defined. So answer the question. Okay, don't tell me that what I'm saying is no use for geometry. No, that is what geometry is using. That's how they're defining their figures. They're defining it as the orbit of a location in the case of a circle. Then they're defining other geometries as itineraries, which form a hollow solid, and so on. These are not my definitions. These are the official definitions of geometry. So it's not like I'm cheating, or that you can say that I'm not using, that you can't use those things for geometry. That's what geometry has. So they have an inconsistency. Don't blame me. This is their problem, the geometer's problem. Okay, and of course it destroys his religion when you put that out there, because you say this is how it's defined, and he doesn't like that. He wants to think that he's looking at a finished product, and it turns out what he's staring at is really a construction of how a geometer constructs the figure. Because all of them are dynamically, those are all dynamically constructed. And they're still constructing them because, again, between any 2 points you find another one. So they're still constructing all their geometric figures. This is not my definition. These are their definitions. And so all he does is just repeat over and over what he learned by rote in high school. Science, rational explanations. First criterion of irrationality, you do not reify. So reification is the first issue there. Criterion for finding out what is an irrational theory. I like to extrapolate that and say that it's an irrational person who proposes an irrational theory. People don't like that too much. And one of them is converting itineraries into geometric figures, which is the case here. Okay? You cannot say that you got an orbit and that you're staring at the orbit of the Earth around the sun and that is a geometric figure. No, an orbit is not a geometric figure. Okay? I don't care if it's a circle, an oval, or whatever it is, it's not a geometric figure. Geometric figure you point to with your finger, okay, like that. There we go. You point to it. Okay, and this is another comment I make for this fellow. He never justifies why we need observation or experiment or evidence in science. Okay, he just says we do. Well, yeah, that's because he learned it by rote. He learned it through, authority. He just memorized it for the test or whatever. And, he believes that because that's what he learned and that's what everybody believes out there, that he just has to follow with what everybody believes. And so it doesn't matter if it's irrational or not, he's going to follow it on the basis of authority. So he never answers these questions. These are the questions he's got to answer. then he never defended his definition of object. We told him, okay, does the Klingon, and let me put that up there again. There it is. Is that table that the Klingon has, is that an object? I mean, he kicks it, he sits on it, he puts his food on it or whatever. Is that table a physical object? And you can't see or touch it because you're gazillions of miles away, okay? And so the question is, does that qualify as an object? Does the word table anywhere qualify as an object? And the answer is yes. The word table is always an object in the dictionary. It's not a concept, it's an object. And so the issue is, what is an object and what is an object for the purposes of physics? And you cannot use the see touch because, again, you can't see or touch his table. And that's the answer that he needs to, that's the question he needs to answer. Okay, and so one of them is that he never answers these questions. He just runs away. Okay? Never defended his definition of object. He claimed to have a scientific definition. And so I did challenge him in the past, said, okay, we showed it to be false, right? Because there is no definition of object out there, and the reason there is no one definition is that mathematical physics doesn't care about objects, doesn't have any use for objects. That's why quantum mechanics doesn't have any objects to explain the mechanisms of the subatomic world. They don't have objects. They use equations, they use, these so-called wave functions, and they have all these terms out there. None of them are physical objects. So you have to define what an object is, because we need to try to give a physical interpretation to the subatomic world as well as to the macro world out there. Okay, so, he claimed to have a scientific definition. What he did is he copied the definition that he found in the Wikipedia. Okay, and again, it's very easy to tear down because that definition essentially goes to the see touch criteria. Okay, falls back on that. And so there is no definition of object out there because math has no use for objects, and math is what is identified as science today. Okay, and so there never was a definition because, again, mathematics has no use for objects or for genuine geometric figures. That's what an object is. A figure is an object. It has shape. If it doesn't have shape because it's still moving or you're still constructing it, then it's not an object. It's not a figure. Okay, fellow also said, brings up another issue, which is experiments. And he says, dropping the pencil over and over, which I do all the time, my famous experiment. We let go of the pencil, falls to the floor. Okay? Pencil over and over is a consistent, repeatable experiment. Okay, yeah, and observing that it falls towards the ground every time. Okay, so we have observation, we have experiment, right? We observe that it falls to the ground after doing the experiment, but 1,000,000 times. It's got to be repeatable to be scientific, according to these people. Now we can make a correct prediction. Prediction is a description. That's all it is. You haven't explained anything yet with a prediction. It will fall toward the ground, right? So that's a prediction. That's all a description, only a description. That's all you said is it fell to the ground. You can say it will fall or it did fall in the past. It doesn't matter whether it's past or future. All you have is a description. You have not explained why, the cause, the mechanism so far. When we let go of that, of the 3D object, which we can see and touch, okay? We let go of it, fine. And again, see and touch, you can't see. If the Klingon does that on the other side of the planet, of the universe, you didn't see it, you didn't touch it. So does that mean what? It never happened? Yeah, you got to answer the question. Is the table, is the pencil, is the circle that the Klingon has over there that you cannot see or touch, is that an object? That's the question you got to answer. If you can't answer that question, then all you're doing is just, putting your cards in the deck. You're just falling short of the explanation that people are expecting from you. You're not defining the word object. You're trying to get away with just authority, and that's all. That's all you have. And again, we can predict the rate of speed. Great. Again, description. This is a very sound theory So far you have no theory. You haven't explained anything. That's what a theory is. That will probably never change. Okay, yeah, so you don't have a theory. You have not, a prediction is not a theory. A description is not a theory. Theory is an explanation. An explanation is not a description. And let me get to another one here. Give me a second. Here we have another issue here. Question a person asks, can you please touch on the issue of inertia? And especially about why objects in motion stay in motion. Well, that's an irrational question. Okay? All motion, we cannot explain the beginning of motion, and likewise you cannot explain the ending of motion. So when you ask a question why objects continue in motion or how objects started motion, you're asking an irrational question. Okay? Motion was there just like objects are there. You cannot ask an irrational question such as, why is there something rather than nothing? Those are irrational questions that mathematicians ask because they never understood the scientific method. That's an irrational question. Okay, so you don't ask why is there something rather than nothing, and why is there motion, or how do you stop motion, or why does an object continue moving unless you stop it. There is no such thing. Motion is a fact of the universe, just like the existence of objects is a fact of the universe. Objects, atoms, for example, cannot turn into space, and space cannot turn into objects. So you cannot ask those questions. Those are irrational questions, and you got to try to figure out why those are irrational questions, okay? And then you mentioned it very briefly before in terms of the rope hypothesis. Well, yeah, in terms of the rope hypothesis, you see it there. Every atom is interconnected, so all you can talk about is inertia, not about motion here. We're talking about inertia. And inertia essentially means that, you know, you have all these atoms which are interconnected. And for this, you have to look at gravity, okay? Not only why we have mass, but also gravity. And the important thing here is that if all atoms are interconnected, when you have that dancer there, she's moving around, the reason her arms kind of stretch out is because she's being pulled by the stars, or you can say that she's pulling against all the stars, which is a notion that was attributed to Ernst Mach, okay, German mathematician, okay, and so what happens here is that her atoms are connected to every star in the universe, and so when she feels a tug, she's really in a way pulling against all those atoms in the universe. Okay? And again, it's not a pull; it's a little more complicated than that. I use the word pull for quick way of explaining. There is no pull. What it is, as an object drifts towards another, the ropes fan out. There is no pull. Okay? But pull is how we identify gravity. We say it's a force of pull. Okay, so that's the word I'm going to use, unless we clarify exactly how gravity works. Okay, another comment, question here. Says, orthogonality is a mathematical term. You not use that in physics. Orthogonality is separation of features in a system. Okay, I don't know what that means. The RPM of your engine and the amount of fuel you have left are two separate features. Has nothing to do with dimensions, which is, I think, what he's referring to here. And we track those features on separate number lines. Number lines, perhaps, not dimensions. We don't use dimensions to track anything, okay? And those number lines we can add together without violating the separation of those features are dimensions. No, they aren't. They're not called dimensions. They're known as number lines, okay? And you cannot use the term dimension without evoking math. It's the other way around. You cannot use the word dimension in math at all. Dimensions are length, width, and height. Those are the three dimensions. There is no other dimension. And those are perpendicular to each other or orthogonal to each other. Fellow says it's a mathematical term. I don't know where he got that. He's certainly irrational when he says that. Obviously, he's more ignorant than irrational. I think. Now here it is, okay, this is what orthogonality means, okay, and yeah, we don't use math to define perpendicularity or orthogonality. It comes from the Latin meaning perpendicularum, and what that means is vertical. It's based on the plumb line. The plumb line used to be called the perpendiculum or perpendicularity, I think it was also. And what it is that the Masons used to have the plumb bob, and they used to hang it from a string or whatever, a little wire. And what they did, what they used it for, is to make sure that their walls were straight. Okay, and what it meant is not that you had a 90-degree angle. What it is that it was vertical with respect to the horizontal plane. That's what it means. We don't need any math, any angles, none of that to define the word perpendicular. Perpendicular simply means that a vertical stands vertical with respect to horizontal. And then you see A and B line stands perpendicular to C and B, and we need no angles. We need to invoke no angles whatsoever to explain. It's a physical notion. The notion is that one is vertical and the other one is horizontal. That's what it is. And that's what perpendicular means, or orthogonal. So the word orthogonal and perpendicular do not belong to math. They belong exclusively to physics. What math has done is quantize those, quantify them, I guess. They started using the word angle, and they started measuring angles. See, angle is not a mathematical term either. It's a physical term. Angle means simply, how much separation there is between two sticks. And they could be perpendicular to each other, the standard vertical versus horizontal, or they could be at different distances with respect to each other, separations. And it's the mathematicians who have quantified that, okay? But it's got nothing to do with physics itself. Physics just deals with the objects, and the objects is, in this case, a little abstract, that you have one line vertical and the other one horizontal, and you're going to have one wall which is vertical and the other wall or the floor that is horizontal. And you don't need any math to understand that. You can just look, stare at that, and say, okay, it's perpendicular. What do you mean by that? Well, I mean that one is vertical and the other one is horizontal. That's what I meant. Okay, very simple. So no, it's not a mathematical term. And then another question here another fellow brings up, and he says, why would the scientific establishment make up black holes? Well, the black hole, they had to explain certain features out there, and they explained two things. One was that what happens to a star is that it collapses on itself gravitationally, and instead of handling it with reason, with rationality, they decided to do it with math. And that's when they screwed up, because they said, well, we have mass. So they started using the word mass instead of objects, instead of things. And they said, well, mass, this concept just goes down to infinity or up to infinity. And we have zero volume, and we will call that infinite, as they use it, not incessant counting, but they call it infinite mass and zero volume, and we'll call that thing a black hole. And that's what a black hole is. It means matter has been crushed out of existence. All you have is location and nothing at that location, and all it has is mass, which is a concept, and that concept apparently attracts physical objects such as stars and gases and atoms and whatever. So that's how it was created. And then they had to explain why stars revolve around nothing. And they said, oh, we figured it out. It's that black hole we calculated mathematically. That's what's in there, and that's what compels the star to go around it. But the issue there is, okay, let's assume that's the case. How does it do it? How is the star that's orbiting this nothingness, how is it connected to the center of that orbit? What physical entity comes in contact with the skin of the star that compels it to go around in circles around nothing, which they say is a black hole? How does the black hole do it? What is the black hole made of that is in contact with a star? That's the question. And for that, they have no answer. So people have to understand that the so-called black hole is just a mathematical abstraction that has to do with math only and nothing at all to do with physics or physical interpretations. Okay, and final question, comment here. Fellow says, what are the holy books and grimoires of mathemagics? And fortunately, that's an easy question to answer. The books and grimoires are known as the textbooks of high school and college. All textbooks are mathemagics because the only thing that any textbook of so-called physics on planet Earth to this day does is talk about force, mass, volume, energy, things that have nothing to do with physics. Physics is about physical interpretations, and you have to start by defining what an object is because you cannot do physical interpretations without an object. Not a single book, not a single textbook of so-called physics on planet Earth begins by defining what an object is, what exist means, and exist is in physics is the science of existence. So none of the crucial words, distance, location, motion, what is a concept, what is space, none of those are defined in any textbook of physics on planet Earth. Okay? They have no definitions for any of those terms, and without those, you cannot give a physical interpretation, and that's what physics is about. With that, I will see you next time. On Sunday. We'll see you then. Bye-bye.